Fellow scientists, the purpose of this video is going to be to work through your blood oxygen graphs, which are on pages 21 through 27 of your student guide. So for this activity, we're just looking at, trying to understand or looking at how to use data. So we're going to be doing some things with this graph here. For this, I am going to kind of be scrolling back and forth a lot. I kind of apologize. It's just the way it's designed. Because we have questions on one page and then we have our graph on the other. It might be easiest if you're following along for you to stay on the questions while I generally kind of look back at the graph. And as always, just make sure you pause. If you need time to write, pause the video, record your thoughts, record your information, and then you can start the video again. That's one of the benefits of this format. So with that said, let's get started. Number one, it says read the title and underline the gas. Okay, so here's our title. Oxygen concentration during exercise and rest. So oxygen is our gas. Number two, it says find the areas of the graph that represent rest and put a box by drawing a square around those portions. Okay, so rest, we have two areas of rest. So we are starting rest, that's like sleep. Well, not really sleep, but just standing still. And then we have levels of exercise, and then we have rest at the end. So there should be a box around the beginning, and then a box around the end. Okay. Next one, it says find the highest blood oxygen level. So we have things in the arteries, and then we have things in the veins. And we'll come back to why those are different later. The highest one, it doesn't really matter, but maybe the second one is slightly higher than that fourth one. So circle that second one. And then number four is the lowest point, which is this guy right here, right? That's the least oxygen. All right, now let's make sense of that, or start to. It says at rest, what is O2 concentration in arterial blood? Okay, so arteries are circles, and at rest is here, and we can see that gives us about 200 oxygen when we're at rest. Number two, it says, what is the O2 or oxygen concentration in venous blood? Okay, so same process. We go to at rest, we go to our vein, and it's over here, not quite 200, we'll call it 185. Number three, it says, describe the relationship between exercise and oxygen in arterial blood. When we're looking for relationships, usually it's like increase, decrease, stay the same, or like more, less, stay the same. It's almost always a variation of one of those three things. And we can see here in our arteries, which is the circles, it doesn't really have any change. We're going to say no change. Your arteries, no matter what you're doing, have about the same amount of oxygen. Number four, describe the relationship between exercise and oxygen in venous blood. Well, this is where we start to see something, right? So here's exercise, and same thing where it's like, is it an increase? Is it a decrease? Or does it have no change? And I hope you can see here that as we exercise, we are decreasing the amount of oxygen in our venous blood. All right, now, kind of the hardest questions, at least going a bit further. It says, describe the difference between the O2 concentration in arterial blood and the O2 concentration in venous blood. Well, we just have to combine our previous two statements, right? Arterial blood has more oxygen during exercise and is not changing, whereas venous oxygen is decreasing during exercise. And there's less of it. That's important. Not only is it decreasing, but there's also less of it. Because in theory, it could be decreasing, but there being more oxygen. But that's not what this graph says. It says venous blood has less oxygen and we have a decreasing amount as we exercise, compared to no change in arterial. Okay, next one. It says during exercise, why is the O2 concentration in arterial blood different from O2 concentration in venous blood? Yeah, so this really gets at what these are. So if you were to connect sort of these two things, arteries and veins, The thing that's missing that exists in between them is muscles. And you could almost just write that in there. It's like arteries go to muscles, muscles go to veins. And then it loops back around, going through lungs, hearts, and all sorts of things that we've talked about. So the idea here is that we're taking this oxygen and we are dumping it into the muscles, right? Exercise uses muscles, so that by the time it comes back to the vein, there's not as much oxygen because we are actively using that oxygen in our muscles. So I would write muscles in between those words here and then use that to respond to your question. And then number 3, it says carbon dioxide is not represented on the graph. Based on your knowledge of biology, predict the relationship between exercise and the concentration of carbon dioxide in venous blood. Okay. So we just look over here. Well, okay, if oxygen's going down, carbon dioxide is the opposite, right? It's that same idea. Is it increasing? Is it decreasing? Does it stay the same? Well, carbon dioxide is going to increase. It's something that we breathe out, right? The more exercise we do, the more oxygen we use, the more carbon dioxide we're producing, just like the balloons in our lab. So carbon dioxide would increase. Number 4, this is for you. It's like, what questions do you still have on that graph? Come up with one extension question. And that brings us to our summary task. As always, for these, especially if you're doing it late, I encourage you just to think about your last week that you've been in class. You know, it's just going to generically ask you about discussions and group work and things like that. So it doesn't have to be based on this topic. You can base it on sort of anything that you've done recently. Then we sort of come down here to a summary. It says, how does the body regulate gas exchange? That's something you should have about your breathing rate, right? So you have to increase your breathing rate to keep oxygen constant, to get rid of carbon dioxide. It says, why do we say, number 2, why do we say that gas exchange is a feedback mechanism? Feedback simply means that you're responding to something. So the more that we exercise, the more that our body has to change, because the exercise is creating that, what we call feedback, right? Constantly changing in order to maintain your body. And then we want to talk about cells, organs, and body systems. So I'm going to give you one thing at each of these that's related. So at the cell level, we had this in our previous video, is the mitochondria, and I'll spell that. That's M-I-T-O-C-H-O-N-D-R-I-A, the mitochondria. That's the thing that's using the oxygen and creating the energy. An organ, you could do the lungs or the heart, whichever you prefer. The heart moves the blood and oxygen around, whereas the lungs are obviously dealing with the actual exchange of oxygen and carbon dioxide. And then for your body system, you could either use the respiratory, if you had chosen the lungs, because that deals with our breathing, or you could choose cardiovascular, which is something that deals with the heart and blood and the pumping of that. So both of those are good choices for this. All right, and then based on everything that you just filled in, go ahead and give yourself a student score. And then on these, like I said, oftentimes you just need to think about, all right, the last time I did an activity, you know, how did my group do? So it might not be on this activity, but just think back to a recent activity and give yourself some scores.